going to be m squared minus 1 is equal to 0. And so we will get m is equal to 1, so m1 is 1, m2 is negative 1 when you solve. So we will have our complementary equation will be c1 e to the x plus c2 e to the negative x. Cool so far? So we can have our y1 equal to e to the x. So y1 prime is e to the x. y2 would be e to the negative x. And y2 prime is negative e to the negative x. Cool so far? All right, so our Wronskian will equal to, the first column is e to the x, and the second column e to the negative x, negative e to the negative x. Well, multiplying through, we'll get negative 1 minus 1, which is negative 2. Have w1 is 0, f of x, which is 2e to the x, over e to the x plus e to the negative x. And then the second column is going to be y2 and y2 prime. Remember that was e to the negative x and negative e to the negative x, which will be 0 minus 2 over e to the x plus e to the negative x. And then our second Wronskian, our W2, our second numerator Wronskian, will be just e to the x, and then the second column will be 0 to e to the x over e to the x plus e to the negative x. Now that's going to end up being 2e to the x squared over e to the x plus e to the negative x minus 0, which is just this, okay? So u1 prime is w1 over w. Well, w1 was negative 2 over e to the x plus e to the negative x over w, which is negative 2. And then we will get a result of negative 1 over e to the x plus e to the negative x. And then u2 prime will be w2 over w, which is 2e to the x squared over e to the x plus e to the negative x. And then I'm just going to say times negative 1/2. And so that's going to be negative e to the x squared over e to the x plus e to the negative x. Now, I think I can work with this one a little bit more. So this will be negative. I'll keep this as e to the x, quantity squared, over e to the x, quantity squared, common denominator, all over e to the x. All right, so this is how it'll shake out. What I'm looking at here is I'm looking at potentially doing partial fraction decomposition, first long division or long division. And then let's go up to u1 prime. Similarly, we're going to end up getting e to the x over e to the x squared plus 1. Cool so far? u1 prime is e to the x over e to the x quantity squared plus 1. So this would give us du1 is equal to e to the x over e to the x quantity squared plus 1 dx. Now let's just clear out that e to the x. Let's let w equal to e to the x. So dw then will be e to the x dx. And notice we have that, right? So we would be looking at the integral of dw, because dw is e to the x dx, over w squared plus 1. But that's just 1 over 1, arc tangent, because our a is 1, arc tangent w over 1, which back substituting is going to give us arc tangent at e to the x. So integrating both sides, we'll just get u1 is equal to arc tangent at e to the x. All right, so now looking at u2 prime. So u2 prime is e to the x cubed over e to the x squared plus 1. Let me make sure I didn't miss a negative on anything. That one does have a negative, right? So it needs a negative. The first one, I also lost a negative. So our result here is going to be negative. All right. So now this one here, let's clean it up a little bit. Why don't we, again, let w equal e to the x, and dw will be e to the x dx. So that's going to give us the integral, negative integral of w cubed over w squared plus 1. Actually, we're going to have w squared dw, because we need one factor of e to the x to be our dw from here. Okay, so here we can do long division, right? So w squared plus 1 is the divisor. And then you've got w squared plus 0w plus 1. And we will get 1 w squared plus 1. And that's going to give us a 0 remainder. So this is going to be equivalent to negative 1 plus 1 over w squared plus 1 dw, which will just be equal to negative w plus 1 over 1 arc tangent w over 1, which is negative e to the x plus arc tangent at e to the x. All right, so bringing this back over here, du2 equal to negative integral of all of this stuff so u2 is going to equal to, I accounted for the negative already, we'll have negative e to the x plus arc tangent e to the x. So now we need to find yp, and remember that yp is equal to u1 y1 plus u2 y2. So yp will be, remember our y1 was e to the x and u1 was negative arctangent e to the x. So we'll have negative e to the x times arctangent e to the x, and then plus, I think that one's negative as well, right? So we'll put a minus e to the negative x, because that was y2, times, actually we'll do this as a plus, and then we'll have our negative e to the x plus arctangent e to the x. So let's see what shakes out. That's going to be e to the negative x. I'm going to make them so it looks pretty. So distributing through here, arctangent e to the x, e to the negative x times negative e to the x will give us a minus 1. And then we'll have a minus e to the x arctangent at e to the x. Cool, cool? All right, so y equals yc plus yp. So the whole shebang will be y equals c1e to the x plus c2e to the negative x plus e to the negative x arctangent at e to the x minus 1 minus e to the x arctangent e to the x. I hope you have a wonderful morning, afternoon, or evening whenever you're watching this show. And if you like what I'm doing, hey, hit that like button and subscribe. Bye.